going to talk about adding and subtracting polynomials. But before we actually do any adding and subtracting, we're going to talk about the characteristics of polynomials and just what exactly a polynomial is. Well, a polynomial is basically a little expression made up of different terms that are separated by addition and subtraction signs. Okay, and some of these have special names that we'll talk more about here in just a minute, but a monomial just has one term. A binomial, bi meaning two terms, and a trinomial has 3 terms, and so on. And like I said, we'll talk more about that in just a few minutes. But first of all, down here at the bottom is kind of an important thing. These are the characteristics of polynomials. Okay? And basically it's describing what they cannot have or cannot be. But polynomials cannot have any negative exponents. They cannot have any variables in the denominator. They can't have any radicals. And no variables can be exponents. So just to mention this again, you can't have something with x to the negative third. Okay? There can't be something with an x in the bottom. Okay? There can't be any square roots or cube roots or fourth roots or anything like that in there. Okay? And we can't have anything where a variable is up there as an exponent. Okay? Those are all characteristics of things that are not polynomials. Okay? Here I have a couple examples. Determine if each expression is a polynomial. Okay, so if we take a glance at those real quick for a second. If I was to look at the first one, 1a, how about just plain old x? Is that a polynomial? It sure is. Yep, it's x to the first power, it's one term, it's a monomial. That one is yes. 1b over here, okay, it's made up of 4 terms, and it meets all those criteria we talked about just a minute ago. That is also a polynomial. Okay, how about 1c though? Can it have more than one letter in it? Can it have an r and an x, a tu and a v? It sure can. It can have multiple variables in it. And yes, that one is also. The letter D here though, this one is a no. Okay? There's a couple things wrong with this one that make it not be a polynomial. First of all, I see a negative exponent right there, x to the negative 4th. Can't have that. Okay, and also right here, it has a variable as an exponent. That's an x, negative 8x to the a power. The x is okay, but it's a little a up there that's not okay. And so one of the things you'll be doing is asking to determine whether or not it is a polynomial. Okay, no fancy math to do, just kind of using the definitions that we talked about on the previous page. Okay, next up here is the degree of a polynomial. And simply put, the degree is the largest power. Okay, and most of the time, a polynomial expression is written in order, okay, and with only one variable in it. So maybe it's something like this. Okay? The largest exponent I see there is a 3. Okay? I would say that that has a degree of 3. Okay, maybe I'll write that right here. The degree is 3. It's not 5x cubed. It's not x cubed. It's just simply the largest exponent. Okay? And most of the time, that biggest one is going to come first. It's usually written in standard form. Okay, which we'll also talk about here in just a minute. Okay, how about if I had something like this? Negative 7x plus 5x to the 4th plus 7x cubed plus 8x to the 5th. Okay, the degree of this one, if I look carefully at all of those exponents, the largest exponent I see, remember that's a 1, a 4, a 3, and a 5. This time it's at the end, and I would say that polynomial has a degree of 5. Okay? All right. However, though, sometimes, what if there's more than one variable in it? What if I had this? What if I had 3x squared y plus 5xy cubed plus 7x cubed y to the 4th? Okay? What if it has more than one variable? Okay? The degree of this polynomial is not just 4. Okay, it's not just the biggest power. When we have something like this, we're talking about the largest sum of all the exponents, okay, of each term. Of this first term right here, remember that's y to the 1st. This one has a degree of 3. And the way I get that is 2 plus 1 is 3. There's another one right there. This one has a degree of 3 plus 1, which is 4. And this one over here is 3 plus 4. This one has a degree of 7, okay, for that term. So the largest degree of the whole polynomial is going to be 7 in this case. So if there's more than one letter in it, we have to add all the exponents together. And don't forget about the little ones that aren't technically written there. Okay? I'm not going to see a lot of these. Most of them are going to be like the others, but every once in a while they're going to throw one in there like that. Okay, so the degree again is the largest power or the largest sum of the powers of each term. Okay? All right. Well, we can also classify polynomials according to their degree and according to the number of terms that they have. If something has a degree of 0, it has a special name. It's called a constant. Okay? And what that is kind of like 5x to the 0 power. And we know from previously that the 0 power is 1. Okay, so really it's not even, any x to the 0 power just turns into a 1, and that's just a plain old 5. Okay, it stays the same. It's going to be a 5 no matter what. It's not going to change in value at all. It remains constant. Okay, if something has a degree of 1, okay, maybe it's like, well, it's what's called a linear function. Okay, it's like 3x. Okay, 3x plus 2 or something. The largest power is a 1. It's a linear function. And those are the types of functions that we worked with in the past when you guys did y equals mx plus b. Okay, it was always the first power. Okay, if something has the second power is the largest power, it has a special name. It's called a quadratic. Okay, and that's where you have something like a 5x squared plus something. But the biggest power is a 2. If the biggest power is a 3, it has a special name. It's called a cubic. Okay. 4 is called a quartic. Okay, like 4 quarters in a dollar is an easy way to remember that one. And if something has a degree of 5, if it's raised to the 5th power, okay, I think it has a special name. It's called quintic. And again, it's not very common, but the way that I remember that is if a lady has like 5 kids at the same time, they're called quintuplets. Okay, quintic is 5. Okay, we can also classify them according to the number of terms in the expression. If it just has one term, and we saw this before, it was called a monomial. Okay, mono meaning 1. That's just like if it was just a 3x, just one term. Okay, and again on the previous screen we saw another one. If it has 2 terms, it's called a binomial. Okay, maybe it's 2x plus 6. There's 1 term and 2 terms. Bi meaning 2. Okay. 3 terms we saw before also, it's called a trinomial. Okay. And then what if it has 4 more terms? Okay. 4 more is simply called just a polynomial. Okay. Poly means many. So 4 more terms, it has many terms, they're going to call it a polynomial. Okay, so that's how we can classify certain terms or certain polynomials according to degree and the number of terms. Okay? Okay, here are 2 of them. Okay? If I wanted to classify this by its degree and the number of terms that it has. Okay, if I look carefully at that first expression there, what's the largest power we see in all of them? It's a 3. And the third power, if I go back here a second, the third power is called a cubic. Its largest degree is 3. It's called a cubic. Okay? And the other thing there, how many terms are there? Well, there's 1, 2, 3, 4. There's 4 terms, and again, I'm going to go back here one second. If it had 4 more terms, it was called a polynomial. This one is called a polynomial. Okay? If I look at this next one, your number 2. If I wanted to classify it by its degree and by the number of terms it has, we can do the same thing. Now, this one's written out a little bit out of order. I think the largest power I see in this one is a 4. And if you remember from a minute ago, if it has a degree of 4, it's called a quartic. Okay? And the number of terms, 1, 2, 3. 3 terms, it's called a trinomial. Okay? So there we have it. Okay, we can classify polynomials according to their degree and the number of terms that there are. So not a lot of fancy math so far. Okay? Another important thing here is this thing called standard form. Okay, standard form goes from the largest exponent down to the smallest exponent, from biggest to smallest. Okay? An example of this one might be this: 5x to the third, 2x squared minus 6x plus 5. Okay? They're going to ask us to write it in standard form and then identify its degree. Okay, in this case, its degree is the largest exponent. It's going to be this one out in front. It's usually the first one. Well, it is the first one. Okay? So this one has a degree of 3. And then they talk about this thing called the leading coefficient. Okay? The leading coefficient is the number in front of the term with the largest degree. And I oftentimes abbreviate this LC for leading coefficient. The leading coefficient is the very first number, the number out in front. It's 5. And notice it's not 5x cubed. Okay? It's just the actual number 5 and only the number 5. Okay? So let me do, let's do one more here. Okay? What if I wrote one that wasn't necessarily in order? Okay, and oftentimes they're kind of mixed up a little bit. How about I had this? Negative 3x squared plus 5 minus 7x to the fourth plus 3x cubed. Okay? Can we find its degree and its leading coefficient? But before I do that, can we write it in standard form? Right now it's out of order. It's not in the proper order. Okay? If I was to write that in order, I'm going to write it with the biggest power first. That's going to be this guy right here. Okay? I would write that as negative 7x to the fourth would come first, the fourth power. I can cross it off. After the fourth power would come the third power. Are there any third powers? Yep, there is. It'd be this guy right here. Plus 3x cubed. I can cross it off. Then would come the squareds. Minus 3x squared, this guy out here. So fourth power, third power, second power. And then would come the x's. Well, I don't see any x's there. There's only a 5 left. Now technically it's plus 0x. But we don't have to write the 0 there. But the very last term of that would be a 5 then. So this is what it would look like in standard form right here. Negative 7x to the fourth plus 3x cubed minus 3x squared plus 5. And then it's very easy to identify its degree and its leading coefficient. It all comes from the very first term out in front. Its degree is the largest power, is a 4, and its leading coefficient is negative 7. Don't forget about the negative. Okay? So again, we can rearrange things, put them in the correct order, and identify its degree and its leading coefficient. Okay? All right, last but not least, is we're actually going to get to adding and subtracting these polynomials. Here's where all the math is involved today, and it's really not too bad. Okay, let's suppose I had one little polynomial. It was this, 3x squared plus 2x plus 1. And I'm going to add another polynomial, 5x squared minus 6x minus 2. And I'm going to add those together. And notice that they're in parentheses. Why are they in parentheses? It's just showing us the first polynomial, the second polynomial, and we're going to add those two quantities together. And really, all this boils down to is combining like terms. Okay, and we always like our answers to be written in standard form. So we want to find the biggest power and write it first, all the way down to its smallest power in the constant. So when I look at these things, I look for the biggest power. The biggest powers I see here are x squareds. Okay, and I have a couple of them and I can combine them. 3x squared plus 5x squared is 8x squared. Okay? And again, if I want to, I can cross them off. Okay? After the squareds come the first powers, just regular x's. Well, there's a couple of those too. I have a 2 plus negative 6. 2 plus negative 6 is negative 4x. And they're gone. Okay, and then lastly, I have the constants. 1 plus negative 2 is negative 1. Okay, and there's my answer right there. Okay, just combining like terms is really all it boils down to. Okay, I'm going to do one more here before we take a look at subtraction. Okay, what if I had this one? What if I had 3y plus 5 plus y cubed? Oops, get rid of this guy here. And I had another one back here. It was 4y squared minus 4y plus 2y cubed plus 6. Okay? So here we go. Again, we're going to look for like terms that we're going to combine together, but we want to do the largest exponents first. Okay, so what I do is I kind of scan the list and I look for the largest exponents, and I see a 3 here. So I see a 2y cubed and a 1y cubed. 1 plus 2 is 3y cubed. And again, I oftentimes like to cross them off when I'm done with them. So I started with a third power. Now I'm going to look for any second powers. Okay, and I see just one of them right there. That first one doesn't have any y squareds. So there's just one of them here, and it's a positive 4y squared. And that one's done. Okay, so I'm going from the third power to the second power. Now how about just our y's? Well, there's a couple right here. A 3y plus negative 4y. And 3 plus negative 4 is negative 1y. And that's gone. And then the only two things are left are the 5 and the 6. 5 plus 6 is positive 11. And there's our answer right there. Okay, so it's nothing really more than just combining like terms. Now if you notice how I've been pointing to that plus sign every time, that's going to be helpful here, especially when we see subtraction in just a second. Okay, all right, so there's adding. Okay, let's try a couple subtraction ones. Okay, how about this one? 6a squared plus 4a cubed plus 7a minus 5a cubed minus 2a squared plus 3a. Okay? So a bunch of a's there. And again, what I said before is I always like to write our answer in standard form. So we're going to look for the largest exponent out of all of these. And the largest exponent I think I see here is a couple cubes, third powers. Now with subtraction, the thing to be careful of, as you guys probably know this, but what does this subtraction sign do to everything in the parentheses back here? It changes the sign. There's like a negative 1 there. And some people like distributing that negative 1 through. You can kind of do a change if you want to, so to speak. And that'd be perfectly fine. I personally just leave it the way it is, and I point to it every time, as you'll see here in a second. So here's what I do. Okay? I know I need to combine these, but I have a 4a cubed minus 5a cubed. 4 minus 5 is negative 1a cubed. And if you wanted to write the 1 there, you sure could. But it's a negative 1a cubed. And I'm going to cross it off, just like I've been doing. So after the third power, I'm going to look for some second powers, and I see a couple. There's one, and there's one. Okay? Now be really, really careful here. It's 6a squared minus negative 2. And you guys know about 6 minus negative 2, there's going to be a change, and it's going to turn into 8. Positive 8a squared. Okay? So minus a negative, we get a change going on. And those are gone. And the last thing that's left is 7 minus 3 is positive 4a. Okay? And there's my answer for that one right there. Okay? Again, be careful with the subtraction ones. They're a little tricky sometimes. Okay? All right, I got one last one. And this is it for the day. And then we're done. Okay? We'll take a look at this one. 8y minus 10 plus 5y squared minus 7 minus y cubed plus 12y minus 5. Okay? And sometimes it's helpful, if it's helpful for you, circle the subtraction sign in between them. Okay, I'm going to scour the list here, and I'm going to look for my biggest exponent. And it looks like the largest exponent I see is a 3. Okay? Now a lot of people are going to look at that and say it's negative y cubed. Well, it sure looks like it's negative, but notice it comes after the subtraction sign. So it's really minusing a negative y cubed. It turns it into a positive y cubed. Okay, so be really, really careful of the subtraction sign with the negative. Okay, after that come the squareds. Okay, and I see there's only one y squared, and it's a positive 5y squared. So that one's done. Then would come my y's, and there's two of them. There's one here and one here. And it's 8 minus 12. 8 minus 12 is negative 4y. And that's gone. And last but not least, I have my constants left. And it looks like it's a negative 10 minus negative 5. And if it's helpful, you can certainly do it that way. I see a change going on there. And negative 10 plus 5 is -5. And you can certainly use your calculator as well. Okay? But as we're going through, I always point to the operation in between the two polynomials. Okay? All right, there we have it. There's adding and subtracting polynomials, and then some little definition of a polynomial and some characteristics of polynomials. Thanks for tuning in.